So rest part, I mean, if the roots are real distinct or roots are real equal, that we have discussed in details, but today we'll just consider only one case, that is roots are complex in nature. And as I have mentioned that if one root is complex, let's say alpha plus I beta, another root will be alpha minus I beta. Okay. So in this case also, the general solution will be C1 e to the power m1x plus C2 e to the power m2x. Okay. And rest part is as it is. The rest part is as it is that we have discussed. Now M1 is alpha plus I beta. So if you substitute here, I will just work on this part only. Rest part I will not discuss anymore here. So it will be C1 e to the power alpha x. You can arrange the term. See, e to the power alpha plus I beta into x. In complex form, you can easily write it as e to the power alpha x into cos beta x plus I sine beta x. Likewise, if you change here in place of alpha plus I beta, if you write alpha minus I beta, accordingly here the sign
Only
will be minus.
minus.
Yes. So if you do some calculation, then you can write the solution in this way. I mean, just see here it will be e to the power alpha x into cos beta x plus I sine beta x. Okay. Plus C2 e to the power alpha x into cos beta x minus I sine beta x. Okay. Now, see here, you have e to the power alpha x cos beta x in both the terms. And there is C1, here it is C2. So C1 plus C2 can be considered as a new constant. Likewise, if you write sine beta x term, so there will be C1 I into C1, and here it will be minus I into C2. That I have written a new constant, that is B. Okay. So basically there will be two constant. Like here that I have considered C1 and C2, here it will be A and B, that you can adjust. You can find C1 plus C2 equals to A, and accordingly you can find B in terms of C1 and C2. Okay. So that will be the part.
Sir, I sine beta x.
Yeah, you just, no. Beta I is B is I into C1 minus C2. Okay. So you can write it. I mean, I we are considering inside the constant. Okay. So then the part coming from this, I mean, if the roots are complex in nature, then you have this part in the solution. And rest part as it is. Okay, that we have discussed. So let us illustrate this with some example. Yeah, this is the fine example that where you have some complex root. So let's say you have the differential equation is d4y dx4. It will be dx4, of course, minus a to the power 4y. So you can easily find auxiliary equation. In last class, we have discussed about how to find the auxiliary equation. So you can easily find the auxiliary equation. M to the power 4 minus a to the power 4 is equals to 0. So you can find the solution of this auxiliary equation, that is values of m in this way. M will be plus minus a and plus minus ia. So this part is already discussed in last class. So the contribution from plus minus a in the solution, that will be C1 e to the power ax plus C2 e to the power minus ax. And rest part, see here, the real part is 0. So real part is 0. See here, if we go into this solution, real part is 0. That means c to the power alpha x will be 1 only. So remaining part will be a into cos ax plus b into sin ax. Okay. So see here, you have a fourth order differential equation, and here you have 4 different constant parameters. Okay. So this can be treated as the general solution. So this is the end of one part, that is how to find the general solution of homogeneous differential equation. But the question is how to find the general solution of non-homogeneous differential equation. Of course, here we will consider the same type of differential equation, that is linear in nature, and the equation must have the coefficient which are constant in nature. Okay. So we'll only the difference here is we will consider right hand side is non-zero function of x. Right hand side is non-zero function x. That can be constant, that can be any function of x. Okay. So we will discuss now how to find the general solution of this kind of non-linear, non-homogeneous linear ODE with constant coefficient. Okay. So so right hand side is non-zero. So here the general here see, I mean we have a let's say nth order differential equation. So in the general solution there must have n number of constant. So we have already seen that in first part, the complementary function that we have discussed. I mean, this is what the solution of the corresponding homogeneous differential equation. So this complementary function already contains a number of coefficient constant. So the another term that comes from this right hand side, it will be free from any constant because all the constant we have already written in the corresponding general solution of homogeneous differential equation that we often call as complementary function. Now, what will be the additional part here? In order to have the right hand side, that is called as PI, that is particular integral. That is particular integral, and the sum of this complementary function and particular integral will be the general solution of the differential equation, which is non-homogeneous in nature. So one question that must comes in your mind that how to find particular integral, how to find particular integral. So in this discussion, we will frequently use CF. CF stands for complementary function, and then we will use PI, which stands for particular integral. So question is
Hello,
how
sir.
to find particular integral. Yeah, I will take all of your question. Please let me discuss a little bit. I will take all of your questions. Okay.
I don't have any questions, sir. Sir, can you repeat the first part a bit, sir? My network was not good.
I mean, see, yeah, I understand. I understand. But in this class, there is 500 students. So if I have to repeat again and again, it will be really tough for me to complete the course. I understand your query issue. Definitely, I will discuss. But let me go through. Okay. Otherwise, it will be really tough because last day I complete only very few portion. Whatever I have decided, I could not complete that one. Anyway, so the general solution of non-homogeneous equation is nothing but, as I am repeating, which is sum of complementary function and particular integral. Now the question is the particular integral will be free from any constant because as we have seen in complementary function, we have already involved all the constant. Let's say you have nth order differential equation. So as we expect that the solution must contains n number of constant coefficient or constant that we have introduced in CF. So in PI, there will be no constant. So definitely there is a question then how to find the particular integral. Okay. So here the particular integral you can see, I mean, if you write the differential equation, how you can write the differential equation? Let's say we are introducing an operator FD, which is nth. This is what the operator d to the power n plus p1 d to the power n minus 1 plus so on pn, and d stand for ddx. So d square will be d2 dx2, that means second order derivative. D3 will be accordingly dq dxq. Okay, so likewise you can find all the derivatives. So the differential equation given here we can write in this way: f dy is equals to x. Okay, f dy equals to x. The differential equation in terms of this operator fd, where fd is defined right here, can be written in this way: f dy is equals to x. That means you are operating fd on y to get the value of x. So the question is how to find y. So you can imagine as if it will be inverse of fd into that you have to operate, not into, you have to operate this inverse operator on x. That means you have to actually find 1 by fd of x. Okay, so let's say you have a problem, left hand side is only d operator is there. You can simply understand y will be 1 by d of x. Now d is differential operator, then 1 by d is integral operator. Okay, but the problem will be more complicated because dy is x is very simple problem. For higher order differential equation, you can have any functional form in the left hand side involving the operator d. And so the particular integral definitely depends on how complicated your FD is and what is the nature of this function x. So we'll consider various types of function x and various form of FD. Okay, to get the value of particular integral. So this will be free from any sort of constant. Okay, because as I mentioned earlier, that CF involves all the constants. So let us consider one by one different function, right hand side function x. Okay. So one function that often comes in our mind, that is exponential function. One of the best suited elementary function is exponential function. So that means you have a differential equation, that is f dy is equals to e to the power ax. Okay. Let's say you have this differential equation. Okay, where fd is that I have already stated d to the power n plus p1 d to the power n minus 1 plus so on pn. Okay, so if you operate that, now our target is to find what is y. Our target is to find what is y. Okay, So let us proceed with the method. So let's say you are operating FD on e to the power x. Let us see what happens. So if you operate FD on e to the power x, what happens? See, d to the power n of e to the power x, you know that it will be a to the power n e to the power ax. Okay. Likewise, d to the power n minus 1 e to the power x, that will be a to the power n minus 1 e to the power ax, and so on. You can find all the values. So basically, if we apply FD on e to the power x, it will give you back a to the power n into e to the power x plus P1 a to the power n minus 1 into e to the power x plus so on Pn a to the power ax. Okay. Now see the term inside the first bracket, it is nothing but f of a, because fd is this term, so you just replace as if d by a. So you will have fd e to the power x as fa e to the power x. Okay. So now see there is two options. That means fa can be 0 or fa is non-zero. Okay. So we have to consider both the cases. So let's say for the time being, we are considering fa not equals to 0. Obviously, we will consider fa equals to 0 case subsequently. So if fa is non-zero, then see from this relation, that is fd to the power x is equals to fa to the power x. If you just divide fa and fd, then what it will be? 1 by fd to the power x will be 1 by fa to the power x. Okay. So this is what your pi, right? And the value turn out to be 1 by fa e to the power x. Value turn out to be 1 by fa e to the power x, provided fa is non-zero. Provided fa is non-zero. Okay. And then we'll consider case 2. But let us illustrate this one with some example for which fa is non-zero. Okay. fa is non-zero. Okay. Then I will come definitely for the case where fa is 0. Okay. So let us see this question. D3y dx3 plus y. So this is third order differential equation. Right hand side there is non-zero term. So we can think of it is non-homogeneous differential equation which is linear in nature and coefficients are constant. So first part, what happened?
Sir,
Sir,
like
can you go a bit
yesterday,
slower?
wait, bro. Sir, like yesterday only, some students are facing the problems, the same problems. So.
See, if you follow the instruction, my instruction, there will be no issue. I have created only single link, one link for today's class. You just join that class only, that link only. Then there
Sir,
will be no issue.
Sir,
Okay.
Pinaki sir has also created a link.
Today I am taking the class. So I have asked you last day to join via my link. If someone is joined there, ask them to join here. Okay. And very beginning, I have told you that one. So in between, if you say all these things, it will be, frankly speaking, bhai, it will be very tough for me. Okay. If you have any other question, please tell me.
Okay, sorry, sir, sorry.
Sir,
No
can you
problem,
go
no
a bit
problem.
slower?
Yeah, that I can do, no problem. Yo, I am
Go a
fast.
bit.
Because you are talking so fast, I cannot follow.
Oh, okay. That I can. Okay, I'll go slow. Okay.
Thank you, sir.
Okay. If you have any this kind of issue, fast issue, or if you are not following me, then I am here to help you. But regarding the joining issue, I have told you last day and at the very beginning, I cannot do anything from my end. If someone create a new link, what can I do? Or if someone is joining with his own her own link, I cannot do anything. Okay, and I am taking the classes in MS Team from last 2 years. I never faced this kind of issue. All of my students earlier, they have followed my instruction at least. Okay, and I am very happy that I have somehow managed all the classes earlier. And frankly speaking, I don't know what is going on with your batch, but all of you are very good students. So hopefully you will follow my suggestions. Okay, so okay, let me go a little slower as you have requested. I am sorry if I am fast. Okay, so here see we have a differential equation given in this example. So as I have mentioned, we are going to consider the right hand side as non-zero now. If it is 0, solution will be complementary function. So I hope all you can find this. So I must give you this as your homework. You please verify it. Nothing, you have to do nothing. Basically, you have to find the solution of the auxiliary equation. MQ plus 1 is 0. So all you know the roots are 1 omega square. That I have written explicitly actually. Okay. So then you can find CF. But let me illustrate PI, particular integral. So particular integral, that will be your 1 by fd of right hand side function. So in right hand side function, there is three different functions. So we'll go one by one. Okay. So first function is 3. So it means see, I mean, it will be 1 by fd of 3 plus e to the power minus x plus 5 e to the power 2x. Okay. So first we will consider 1 by fd of 3. Then we will add that part with 1 by fd of e to the power minus x. And then we will go for 1 by fd into 5 into e to the power 2x. Okay. So these three part we have to calculate, and the particular integral will be sum of all these three. Okay. So let us go slow and let us see what will be the case for this part. When a right hand side function, let's say the first part, that is 3. So see, 3 is there. It is not given in e to the power x form, but you know 3 can be written as 3 into e to the power 0x, because e to the power 0 is 1. So here a is 0. And what is fd? That is your 1 by dq plus 1. So what will be f0? That will be 1 by 0 plus 1. Okay. 1 by 0 plus 1. Right? So 1 by 0 plus 1, that is non-zero. Right? So the answer will be what? 3 by 1 into e to the power 0x. That is 3. Right? Now, another part 1 by dq plus 1, that involves a factor d plus 1, which will be 0 when you substitute d equals to minus 1. So we need further treatment to calculate this function, the particular integral for this function. So I will discuss this once I have done with the case where fa equals to 0. So I will not discuss this part right now. I will come first the theory for fd equals to 0, fa equals to 0, then I will discuss it. But last part, that is 5 e to the power 2x. Always remember 5 is a constant, you can take it out. So the remaining part is e to the power 2x by dq plus 1. Here fd equals to again dq plus 1. So a is what? 2. Now f of a is what? 2q plus 1. Right? So that is non-zero. Okay. So fa is non-zero. So you can say it will be 1 by fa into e to the power 2x. And 5 is already there. So it will be 5 by what it is? It is 9. So 5 by 9 e to the power 2x. So the last contribution is 5 by 9 e to the power 2x. First contribution is 3. But this part we will discuss now. Why? Because it involves fa is equals to 0. Okay. So I will come to
Yes,
this
sir.
part later. Okay. So let me now consider fa is equals to 0. Okay. So you have fd, we have started with fd. Now we are considering that fa is 0. That means in fa there is a factor like this d minus a, or there is a factor like d minus a third square, or there may be a factor d minus a to the power r. Because see, fa 0 means what? A is a root of fd. That root may be appearing one time, or the multiplicity of the root may be any integer r. Okay, so we'll consider all the possible cases. So first and foremost, we will consider a single factor case. That means the root f has a root a which is not a repeated root. Okay, f is 0 at only at a and it is not repeated. Okay, it can have different root also. Okay, like it can have 2 roots, 3 roots. They are unequal. They are not repeating. All those cases can be there. But let us see first. We are considering here a very simple case that d minus a is only the factor, not d minus a square, not d minus a to the power r. Only one factor is there. Okay, I will subsequently consider cover all the cases. Okay, don't worry. Now see, fd is, see, since we have mentioned that d minus a is a factor and a is single root. So fd can be written as d minus a into some other term of d, and that should not be 0 at a. Because if it is 0 at a, that means this is not a single root. The multiplicity of the root may be greater than 1 for that case. That I will discuss later. But let's say phi a is non-zero because a is a single root. So then this is what the pi that I have written here, 1 by fd e to the power ax. Okay. So see, fd can be written as d minus a into phi d. Okay. Now see, this phi d is non-zero when d is a. That means phi a is non-zero. So the contribution for this part 1 by phi d, that can be written as 1 by phi a. And remaining term will be 1 by d minus a to the power x. I mean, just see, you have two operator 1 by d minus a into 1 by phi d. So because of this operator 1 by phi d that we have already seen here, that it will be 1 by phi a. Now we have to work on 1 by d minus a, that is operated on e to the power a. So this third bracket term is that we have to now consider. Okay, so let us denote it by a new term, that is capital Y. So 1 by d minus a e to the power ax we are considering as capital Y. That I have mentioned here, that we are writing right here. So now we'll find what will be the value of 1 by d minus a e to the power ax. Okay, once we are done with this term inside the third bracket, we can simply find the particular integral. We can simply find the particular integral. So you have now y equals to 1 by d minus a e to the power ax. So we have to find this value of y. So let us try to form a differential equation out of this relation. Okay, so you can simply say then d minus a y, d minus a if you operate on y, that will be e to the power x. And it is what? A linear ordinary differential equation of first order. You can write it in this way also. Dy dx minus ay is equals to e to the power x. This is linear differential equation of first order. So how to solve this linear differential equation? So the general form is dy dx plus py is equals to, if you have this kind of equation where p and q are any function of x, that can be constant, that can be any function of x. So here capital P is minus a, capital Q is e to the power ax. Okay, so this is the standard form of linear differential equation of first order. Okay, so then what will be the factor that we multiply the differential equation to make it exact? That is called as integrating factor. Details of the same will be discussed more clearly by Professor Paul. But let me introduce this one. I mean, then it will be good for you to follow his class. So integrating factor is nothing but a factor. If you multiply that one into the differential equation, it makes the differential equation as exact differential equation, and you can simply integrate the differential equation then. But there is a very simple formula. This formula is very interesting. See here, you have to find integrating factor, that will be e to the power what? It will be power integration p dx. Okay. So it will be, I think in 12th standard also it was there, right?
Yes, sir.
Yes, sir.
We were
Yes,
taught.
yes. Yeah, nowadays it is there. Actually, when we were student of 12th standard, it was not there. So sometime I forget that. Anyway, you are very good, that lucky that you have learned this subject earlier. So very good. So integrating factor is e to the power minus ax. Okay. So the solution will be y into integrating factor, that you know already, integration of integrating factor into right hand side dx. That's what I have done here. Okay. So here y to the power a minus ax, right hand side will be e to the power minus ax into the function q dx. And this product is 1. So you can integrate it and get the value as x only. So y will be x e to the power x. Right? You can simply write then y equals to x to the power ax. So that is what our, yeah, that is what y. We are interested to find y. So substitute that in this particular form. So it will be 1 by phi a into the rest term that we have just now derived, that is x e to the power ax. X e to the power ax. E to the power ax. Okay. So this will be the particular integral when we have a single factor, that is a is single root. Okay. So definitely we have to consider the more typical cases where the roots are not single, roots are repeatedly appearing into the equation. That I will discuss subsequently, but let me illustrate this. See, we have already considered one example, that this part that I have asked, I have mentioned that I will come later to solve this. Here we have a single root in fd which goes to 0 when d is minus 1. See here, we can 1 by dq plus 1 can be factorized in this way. 1 by d plus 1 into 1 by d square minus d plus 1. All you know that. Now this is what your phi d actually. So phi d is your now d square minus d plus 1. And a is what here? See, a is minus 1. So phi of minus 1, you can easily evaluate. Phi of minus 1 will be this one. Okay. So that is what? 3. So 1 by phi a is 3. So this term, this term is constant now, so you can take it out. So it will be 1 by 3. And remaining part is 1 by d plus 1, which goes to 0 when d is minus 1. So this is what the part that we have just now solved. This is your capital Y. And we have seen that capital Y will be x e to the power minus x e to the power ax. X e to the power ax where a is minus 1. So the particular integral, the contribution from this part will be x by 3 e to the power minus x. So this part is done now. So sum of all three contributions from the first part 3, second term e to the power minus x, and third part 5 e to the power 2x. You sum them up to get the value of the particular integral, and then write general solution. General solution will be sum of CF and PI. Okay, that will be the general solution. Again, you
Sir,
remember one thing. Yeah.
sir, why
What?
we substitute d equal to -1?
Are you really following my lecture? I have shown that at the very beginning of this lecture. See here, I have discussed that one. Why we are substituting? I have discussed that one. See,
Okay,
FA
sir.
is
Okay, sir.
non-zero. Yeah,
Yes,
so
sir. Understand. Understand.
you
Okay,
please
sir.
follow. Okay.
Yes, sir. Understand.
I mean, no. I am always happy to listen your question, but बेटा देखो, हाँ, जो हम बोल रहे हैं थोड़ा सा सुनो, ठीक है? There will be no issue then. Okay, okay, no problem, no problem. So now we'll consider another case. That is, A is a root, but A is double root. I mean, multiplicity of A is 2. Okay, then we will extend this concept for any order group. That means we will then consider this case, general case. Okay. So A is double root, that means R is 2. Okay. So f of d, I mean, since A is root, so there must be a factor d minus A. Since A is repeated twice, so the order of that factor will be d minus A square, and the remaining term is psi d. And of course, psi of A will be non-zero. Okay. So then see how to find d minus A square. This term is very important. So see, here we have 1 by d minus A square into 1 by psi d to the power x. So this part is done already. 1 by psi A, psi of A is not equals to 0. So you can write it as 1 by psi A. And next term is 1 by d minus A square. So I have written this term as 1 by d minus A into again 1 by d minus A, because 1 by d minus A can be square can be written in this way simply. Oh, we can understand that one.
Yes, sir.
Yes, great. So see, now let us denote the term inside the text. These terms, see, 1 by d minus A e to the power ax. We have already solved this part, right? D
Yes,
minus A e to the power x,
AX.
we have already solved. That is
Yes, sir.
x e to the power ax, right? That we have solved. It is x e to the power ax. Actually, we have not written here. See, when you integrate, there will be actually x by 1. 1 is not written directly here because 1 has no impact. But when in next phase, we will have a factor 2. And then 2 into 1, that means factorial 2. That type of thing will come. So that's why I remind you here, actually there was 1 that I have not written. Okay, because 1 makes no change. But when we'll deal with square or d minus A to the power r, then this makes some sense. I mean, consideration of 1 that I will discuss. Okay, I will come to that point later again. Okay, so here we have b minus A now, and this part is already known. Let's say that is x e to the power minus x e to the power x, that we have solved. Now we have a term, now see 1 by d minus A, that you are operating on x e to the power ax. So let's say the whole term inside the third bracket, we are considering that as z. Okay, then again, we'll follow the same method. We'll construct a linear ordinary differential equation of first order. Okay, and then we'll use the technique of
Integrating
finding the integrating factor. All you know, great. So z is this one. So you can form the differential equation in this way. Then just multiply d minus A to form the differential equation. Again, see, it is linear differential equation. So right, integrating factor is quite straightforward. That will be e to the power p dx. P is minus A. Okay, so integrating factor will be to the power minus A. And solution, that is z into integrating factor, and right hand side will be integrating factor into the right hand side function, right? So this is what the integrating factor, this is what the right hand side function. Okay, so see, z into e to the power minus x integration x e to the power ax into e to the power minus x. So you can cancel e to the power minus ax. Okay, so you have now x dx. Okay, basically you have already earlier you had this by 1 actually that we have not written. So like this, you will have this term actually. So then what it will be? X square by 2 into 1, right? So it will be x square by factorial 2. Okay. Now if you consider here d minus a are q psi d, then what will be the case? It will be the pi will be then what? It will be 1 by psi a, 1 by d minus a. Pi will be 1 by psi a, 1 by d minus a, x e to the power x by factorial 2. Right? Then it will be actually 1 by psi a. If you construct the, again, if you construct the similar linear first order ordinary differential equation, answer will be x cube by 3 into 2 into 1. That means factorial 3. Okay. So then you can easily say that what will be the situation if there is a factor d minus a repeated r times, then it will be 1 by fd. Here it should be psi d. Actually fd or psi d, whatever you wish. I have used the notation psi d, so better to make it psi d. Okay, so it will be 1 by psi a x to the power r by factorial r e to the power x, right? X to the power r factorial r e to the power ax. Okay, x to the power r factorial r. So it will be, just see here, you have a factor, new factor, that is x to the power r by factorial r. Okay, so let us see some example where you have repeated root. I have not included any case here, but I can solve some problem here. Let's say you have a problem like this, very simple problem. Let us consider d minus a to the power 4y is equals to e to the power ax. Right? We will only find the particular integral. CF part is done. CF part you please solve. This is your homework. I will share you the I mean highlighted PDF as well as the original note. Original note is already uploaded. This portion I will share you so that you can see all the calculation. So CF is already done. So you please consider this as your homework. Now see here what will be the particular integral. So as per rule, this will be d minus a to the power 4 that you have to operate on e to the power ax. So see here we have, see here the root, I mean if you write fd, that is d minus a to the power 4, and if you write psi d is technically 1 here. Psi d is technically 1 here. Okay, so psi a is always non-zero. Psi a is always non-zero. There is no need technically, but this psi d cannot be 1 always. That I will give you another homework. So see, so its value will be what then? It is repeated 4 times. So answer will be x to the power 4 by factorial 4 e to the power ax into 1 by psi of a. Psi of a is 1. Psi of a is 1. So the answer will be x to the power 4 by factorial 4 e to the power ax. Let's say another example. One problem you have given, that is d minus a to the power 4 e to the power ax, y is equals to e to the power x. Same problem, but another factor is I have considered here, that is d. Okay, so see here you have fd is equals to d minus a to the power 4 into psi d, right? Where psi d is 1 by, where psi d is d actually, where psi d is d. So psi of a is a, that is non-zero, let's say. Okay, let's say we are considering a is non-zero. I will give you the homework for a is 0. If we solve it for a is 0. Now see, so see here these we are considering for the timing a non-zero. Accordingly, you solve it when a is 0. So see here you have this differential equation. So pi will be what? 1 by d into 1 by d minus a to the power 4 e to the power x. So you can write it as 1 by d minus 4 to the power this into 1 by d to the power x. What will be this term? 1 by d to the power x.
1 by a equal.
See, d is different. Yeah, these. Okay. Your answer is correct. Let me tell you that. For other student may follow. D is differential operator, right? So 1 by d, I have mentioned earlier also, integral operator. Okay. You remember that one. So it is integration. So it will be 1 by d minus a to the power 4 e to the power x by a. So it is 1 by a, 1 by d minus a to the power 4 e to the power x. This part is already done in previous problem.
X to the power
Right?
4
So
factorial
you,
e to the
you
power
can, you can solve it and try to solve it considering a is 0. Not only this, you can form any problem out of it. Any factor you consider here other than d minus a to the power 4. You can form your problem on your own actually. Okay. But remember, right hand side, you are now considering only e to the power x. So one question that often comes in our mind, why e to the power x, why not others? Definitely, we have to consider the other functions that I will consider now. Okay, see here, I have considered x to the power n. Actually, this is enough to consider any polynomial. If you consider the general term in a polynomial p, let's say a0 plus a1x plus a2x square plus so on an x to the power n. So these are all coefficient a0, a1, so to so on an. So better to consider any general term and see what happens. Then you can simply implement that for polynomial case. So it is actually a case where x is any polynomial. Okay. So that's why I have considered the general term, because polynomial only one term is enough. Other term accordingly you can find. Okay. Other term accordingly you can find. Okay. So let us see how to solve this type of problem. When you have a polynomial, or let's say for the time being we are considering x to the power m, only the simplest polynomial. And it is the most suited one. You can generate any polynomial out of this general term. Okay. So the particular integral that will be 1 by fd x to the power n. Okay, that is from the definition itself, where fd is the general operator that we have mentioned earlier also. Okay, I mean you have the equation of this form, that is you have capital X, which is x to the power n, where fd is d to the power n plus p1 d to the power n minus 1 plus so on pn. Okay, so here actually there is no simple formula here. Only the thing that you have to use binomial expansion. That means 1 by fd, 1 by fd, you have to expand it in terms of binomial series of d, but try to expand the series in ascending power of d, in ascending power of d. Okay, this is what we have to do. There is no simple formula for this case. Unlike e to the power x, we have two simple formula. Okay, that we can derive from theory, but here there is no simple formula. But this is certainly very strong method that will help you to find the solution in a simple way. Let us see how can we find the binomial series for fd in ascending power of d. Okay, so see here 1 by fd, the problem that I have considered, dq plus 3d square plus 2dy is x square. Right hand side is x square, m is 2. Again, see, to find the general solution, that you know, general solution will be CF plus PI. So CF I have directly written. You please verify it. Hopefully all you can do that. This is your homework. You can do that because you have to just find the, here the auxiliary equation will be this is 0, mq plus 3m square plus 2 is 0, 2m will be 0. So you can simply find the values of m to get the value of CF. But our target here is to find PI. Our target here is to find PI. That is, here it is 1 by dq. FD is what? I mean, here FD is this. So 1 by FD will be dq plus 3d square plus 2d. That you have to operate on x square. So as I have mentioned, you have to raise FD to the minus 1th power. I mean, negative power, and arrange the term in ascending power of d. So actually, idea is 1 by fd. You have to write in this form, like 1 plus some function of d. You have to write, and then only you can expand. Right? See, you know 1 by 1 plus x formula, or 1 by a plus x formula. Better to write 1 by 1 plus x. That is the most easiest one. So you arrange 1 by fd in that way. 1 by 1 plus x, where x can be here not x exactly. I mean x that you know from binomial series. So that's why I mentioned. But here it will be d actually. So see here, take common 2D to make this term 1. To make this term 1. Okay. So the lowest power you take common. Here you have dq 3d square 2d. You may say, why not dq? You can try to do that one, but it will be very tough job for you to if you expand it by considering 1 by dq common. You can do that, but it will be really very complicated. You can, but it does not mean that you cannot do. You can do any combination you can consider, but better you consider the simplest one, the lower power of d. Okay. Okay, so you may consider other cases, try to do that as your homework. But remember, in order to get the solution in less number of steps, you consider the lowest power that appearing one in FD as common to make it 1. So that's why I have considered 1 by 2D common to make it 1. This term will be 1, then remaining term will be what? 1 plus dq plus 3d square by 2d. And it is in the denominator, so power should be -1. So now as if it is your new x, capital X, let's say, you have to expand it using binomial series. And all you can do that. So it will be 1 minus, let's say it is capital X, so 1 minus x, it is capital X square minus capital X cube and so on. So the question is, how many terms we will consider here in the series? It is an infinite series. How many terms we will consider? That depends on the power of x given here.
Yes, sir, 2, sir.
Yes, right? Because see, x square is there. So if you consider dq, if you operate that on x square, it will be 0. So d4, if you operate that on x square, it will be 0 automatically. So you have to stop yourself with the power d square only. Okay, so see where you can have d square term and leave all the other term, because other term has no sense here. That will be 0 automatically, because dq x square is 0, d4 x square is 0. So apparently look like when you expand this 1 by fd in terms of ascending power of d, most of the term will automatically go to 0, because you have considered a finite order term here, x to the power m. M should be finite. Okay, finite positive integer. So for this example problem, see here you have x square. So we'll consider only the term which will gives us a factor d square. So definitely first term there is no issue. Second term there is no issue. In third term you have d to the d square third square. So e to the power d to the power 4 will be there. And again 2d square into 3d, that is dq order. So we'll drop that term. Last term is will be what? 3d square by 4. That is 9 by 4 d square. That term only we will consider. So it will be 9 by 4 d square. So in this big term, we will consider this term only, because rest term there is no point to write, because it will give you 0 value. So this 9 by 4 d square, and if you operate that on x square, it will be what? 9 by 4 d square into 2. Sorry, 9 by 4 into 2. So that's what the last term is, 9 by 4 into 2. Now see the first term, 1 into x square is x square. Next, d square into x, d square of x square, that is 2. 3d that you are operating on x square, that will be 3 into 2x. So 6x. And denominator is 2. So 2. So now you have to rearrange. Okay, so see, you have to do some more calculation, I must say, because see, 1 by 2d is there. 2 is no problem, but 1 by d is there. 1 by d means integration. So you have to integrate this remaining term. Right? You have to integrate this remaining term to get the exact pi that I have done in next slide. See, so you have 1 by 2d, this term that I have rearranged and then integrate it. See, I have mentioned that one also again, that I have already talked about. So you have to integrate. You remember this one. It's very simple, by the way. I have also mentioned. So integrate it. If you integrate it, you can get the particular integral. And at the end, you please explicitly write CF plus pi is the solution. You please write the expression for CF plus pi. Though I have not written, but you do that. Okay, you do that. In as well, you do that. Okay, so this is what two different functions we have considered. And then I have considered few examples. You solve these problems. Okay, you solve these problems. Okay. So then we have sine x and cosine function. So subsequently we'll consider other functions. But time is 9:50. So I must stop here. You might have some other class also. So let me stop the recording. And if you have any query, you may ask me now. There is no issue. I will definitely give you